Alrighty. So we are now on, I think, like part 50 something. I don't really remember exactly where, but we left off here at of the nearest from Josephus. So we're just going to continue here. They're talking about, I think, some astronomy stuff in the last video, talking about like some of the stars and systems and whatnot. So we're just picking up where we left off. So, wherefore, on account of their virtue, as well as for the perfection of the arts of astronomy and geometry, which they invented, God permitted them, the patriarchs, a longer life, inasmuch as they would have been incapable of predicting anything with certainty, unless they lived 600 years, for such is the period of the completion of the great year. This is of the Saurus from Suidas. Saurus, a measure and number among the Chaldaeans. Oh, that's right. For 120 Sauri, make 2,222 years. Each Saurus is therefore equal to 18 years and 6 months. Yeah, so this is something I think that was used in some like I think the Sumerian tablets, but I think they're in Akkadian, and this word sorry is like it refers to like well, I guess 18 years and 6 months. I don't remember exactly, but they do use sorry, and they use this dating, and that's why the dating for some of the ages of these like great kings is so long. They measure them in sorry. I don't know if this book did it, but I know that I've heard this word definitely before. I could maybe do some more background on it. Maybe we can get some knowledge on this, on like where the word sorry comes from. So let me here, I'll just pull up the AI right here on the screen. So we'll look up where does the word sorry or saurus. I'm pretty sure it's sorry, but and saurus is like a Roman translation. But I really want to know, okay, so where does the word sorry or saurus come from, and how and why is it measured different from an Earth year? Let's see what the AI says. Let me open the screen up more. One thing I'm kind of interested in is the brightness on this monitor, and if the brightness of this monitor affects like my actual video output. I'm kind of like curious about that. So I like recently lowered my brightness down a lot because it gets a lot darker now in the mornings when I get up and start doing these videos, basically. So it's like still dark. Okay, so anyways, aside from that, I was completely off topic. An astute question, the word sorry, completely different. Okay, so let's see what it turns here. The word sorry, the garment. Sorry. Oh, no, this is not something. The word saurus, the cycle, the bird. No, then why are these all in Hindi? This isn't what we're looking for. Oh, here we go. The Saros cycle measurement versus an Earth year. No. Oh, here we go. Oh yeah, look. Well, this one says 18 years, 11 days, and 8 hours, but this one says 18 years and 6 months. That's interesting. Okay, so here it is. So why is the Saros measured differently from an Earth year? The Saros cycle is measured by lunar cycles because its specific purpose is to predict the reoccurrence of eclipses, which are fundamentally a Moon-Earth-Sun alignment phenomena. Earth year, the tropical year, is 365.242 days. That's why we have a leap year. Okay. So the Saros cycle. This is a measure of the synchronicity of the moon's orbit with respect to both the sun and the Earth's orbital plane. What the heck? why are they measuring moons? That's so weird. This has something to do with like the way they were looking at the sky thousands of years ago. I mean, I know it was really important, but yeah. All right. Well, so it's like a it's like basically like one whole revolution of like the point between where the positioning from the sun and the earth and the moon are. Okay, so that's why it's 18 years. So it takes 18 years for. So does it take 18 years for one solar eclipse? Is that what it's saying? So does it take 18 years for one solar eclipse? Sorry to go on a tangent here, but I really want to. I kind of want to dive into this and kind of like know a little bit more about this. I didn't really do any research, and I think some people actually really don't know this at all. I'm assuming people don't know this at all, because when I came across this, I don't know why it became 18 years. No, it does not take 18 years for one solar eclipse to occur. Solar eclipses happen on average every 6 months, and sometimes even more frequently. The 18-year period of the solar cycle is the time it takes for a nearly identical solar eclipse to happen again. Oh, okay. I see. Okay, so it's giving me some interesting stuff. Okay, so it's a lot of like moon calculation stuff with orbits and whatnot. Okay, so it takes 18 years, right? When an eclipse reoccurs after one Saros period, it will be the same type. It will have a very similar duration. Oh, it's so confusing. Well, it just has to do with like the moon and the earth orbiting along with the sun, and then how the moon. What the heck, dude? This is so confusing. This world is so weird. Alright, well, anyways. I don't even know how to explain this, and like, even if I do explain it, I just feel like I'm not like. I feel like I'm just like. I guess I can explain it kind of. I mean, I'm kind of explaining it okay, but I don't know. It's just really interesting. I didn't really know that about the dating of Asari, but it's now like making me ask questions like, okay, well, why do they use that dating? You know, like what purpose does it serve that they were using it back then like that? Like, cause I have one theory, and I have one really strong theory about why that is, but it's I don't know. Like I said, there's other videos that I can go into more detail about that, and I think I will continue on that, but not in this video for sure. So, this part of the Rising of the Dog Star from Theon Alexandrinus. Okay, so I'm assuming this is also a biblical author, right? So let me just pull up the AI again. All right, so let me look up, just double check. Who is Theon Alexandrinus? What is it? Alexandrinus. Let's see if we can pull it up. Oh, oops, sorry. Theon. Okay, so this guy lived from 335 to 405, so that's like kind of during Constantine time. Greek scholar, so he probably like was. Okay, it says he worked in Egypt, Alexandria. Okay. Because they had a library in Corinth, and I know Corinth has like a really important library for a lot of history. Okay. Where do I want to go with this? Well, we know that he's like a scholar from like the time of Constantine, basically. Like late Roman Empire period. Well, I guess like, yeah, I guess like mid Roman Empire period. It's like I think it splits at this point at around 364. I forget exactly when, but there's like a western and an eastern. But aside from that, so this guy has knowledge of the dog star, and if people are well versed with the dog star, I think that's Sirius A and Sirius B, right? So it's really bright because these two stars are very close to each other, and I think honestly, I think one they like orbit each other in some odd fashion, and it becomes a lot brighter. And I think with the naked eye, I think you can only see it as a one giant star. You can't see it as like two stars, so it's I'm pretty sure it's Sirius A and Sirius B. And what's interesting too about that star is actually there's a I think there's a like West African tribe, like native tribe, where they know of the like dog star as well, and they know that it's actually two stars. And like I said, the only way you could know that is if you have like a telescope and you can't see the two stars with the naked eye. You can only see one. But these people, like, I guess they knew of it, and then not only did they know of it, they also like celebrated one whole revolution. I think it's Sirius B revolving around Sirius A. I would assume to myself maybe they revolve around each other, but I don't know. It's kind of the same thing with like Jupiter and Earth, because Jupiter has like so much mass that it causes the sun to like get pulled into it. I don't know. That's what they say theoretically. I mean, I really can't show that. I don't study astrology. I study electrical engineering, so I'm not really too keen on that. But that's what they say, and I'm kind of in agreement with in terms of measurements. You know what I mean? Like it's, you know, it's still up in the air for me whether this is a flat Earth, and for all we know, all these stars and planets could really just be like openings of like a giant light. I don't know. I really can't say for sure. Yeah, I know they said we have telescopes, but I mean, what are we really looking at, you know? We don't know. We can't touch it, right? So, in any case, let's get on with this document because we're almost done with the book. So let's just keep continuing forward. So, formula to find the rising of the dog star. For example, if we would find the rising of the dog star in the 100th year of Diocletianus, we take the years of Menopheres to the end of the era of Augustus. These years summed up are 1605, to which if we add the years from the beginning of the reign of Diocletianus, I can't even pronounce this guy's name, Diocletianus, we have 1705. Let us take the fourth part of these, that is 426, and taking them as days, and add them 5 more, and they become 431. From these deduct the quadrienniums, which are 102, and there will remain 329 days. Distribute these into months of 30 days each from Thoth, the first day of the year, and it will thus be found that the rising of the dog star in the 100th year of Diocletianus falls upon the 29th of Epiphi. Use the same rule for any other time. Dude. Oh, it just reminds me of like those dumb videos I get where it's like add 10 plus 13 minus 5. What number do you get? Let us know in the comments below. It's like that type of stuff that just kind of reminds me of it. Just kind of stupid. I don't know. It's not really stupid. It's just honestly, what is this even saying? It's just telling you to do a bunch of like math or pull out this equation. But honestly, I could just be overlooking what it's actually saying. I mean, if I could just type this in with AI, I could pop out an equation, but I don't see the purpose in us doing that, or what it could tell us in terms of like where things are at. At least for me, I can't pull anything from it. Oh, look at that! Looks like we're almost we're like at the end of the book. An inquiry into the method, objects, and result of ancient and modern philosophy, and into the trinity of the Gentiles. Ooh, that's a strong word. Philosophical inquiry. Okay, wait a minute. Okay, so this is now Cory's like own words. This is no longer like just kind of like some summaries, some like what is it called? I forgot what the textbook sources are called, and like there's like primary sources, secondary sources, and then there's like this is like a third one. It's like synopsis or something like that, or some like a fact or something. I don't know. Anyways, this is like the author's words himself, so he's like kind of now going to be explaining like his interpretation on all of this and what he sees about all of this. And as we've been going through this book, you've seen how I see all this stuff, and now you can take what I see with all this stuff from each video, and now you can take everything that the author now wrote down and put together and what he thinks of all this stuff, and then now you, the viewer, see this and draw your own conclusions from all of this and have your own perspective on it. And now you have three. You have three ways of looking at what was said and how it's being passed down to us. And that is like super important because everybody's going to have their own interpretation essentially for everything, right? Not everything's going to be exactly the same. There's no way. It's almost like maybe one thing a lot of people will have like something in common with the same idea for it, but for the most part, everything in this book that was laid down, I don't think anybody has 100% the same interpretations from one to another. I think there's always going to be something slightly off, and to look at all of it and to put it all together and then kind of draw conclusions from it will also be different from anybody who's trying to draw conclusions off of either somebody else or their own conclusion or their own perspectives on everything that was written down. So now I guess I'm just kind of doing some sort of like inception type of thing where I'm just kind of now taking a look at what the author's saying and then interpret what he's saying to you, and then from there it just kind of, I don't know, you can just it's also important too because this book was also again written in the 1800s, so this is also a different perspective from anybody else's that's contemporary or alive right now. So it's always just good to you know, whenever you're picking apart history, you always want to look into everybody's perspective and conclusions that they draw from it. Don't ever take one person's history to be the only history, because history is all about looking at something and then drawing conclusions from it. It's like being a what are those the special victims unit, the Law and Order thing, what are they called? Forgot the word for it. Darn it. Private investigator, but forensic investigator, something like that. You have to look at this stuff as if it's like not necessarily criminal information, but as if it's evidence. And to use that evidence is very important, especially like in the court of law, right? So we're imagining that we have to take this to the court of law and prove this, just as we would with anything else. And this is the evidence here. So let's take a look at what they're saying in the 1800s. So in the introductory dissertation, I have ventured to offer some speculations upon the trinity and theology of the Gentiles, which differ widely from the opinions of almost all who have written upon the subject. I would therefore lay before the reader such grounds for the opinion as have induced me to adopt it, but I find it impossible to do so without instituting a short comparative inquiry into the method, objects, and result of the ancient and modern systems of philosophy, and I trust it will not be deemed misplaced, for I conceive that in the neglected writings of the ancient there lies concealed a mine of metaphysical knowledge of such practical utility as would amply repay the trouble of opening again. If we were to ask what was conceived to be the great engine of invention and discovery among the ancients, it is highly probable we should be answered that it was syllogism. And if we were to ask the same question relative to modern science, we should be unhesitatingly assured that it was induction, and possibly at the same time we might be told that the method of the ancients was something worse than useless. Yet, when we come to consider that in all ages human nature has been the same, and that such admirable productions have been the result of human effort both in ancient and modern times, we shall find a reason to suspect that the methods of discovery, or the tools really used in all ages, have been much alike, though their names may have been misapplied, or they may have been used without having had any distinct appellations assigned them. By the inductive method we are supposed to go about to collect, by experience and observations, all the facts and circumstances within our reach relative to the subject in hand. We must examine them in every light, compare their similarities, and mark their differences. We must reject whatever does not properly relate to the subject, and conclude upon the affirmative that are left. By these means, from the individuals we rise to some general proposition, and we rest assured in its truth as proved experimentally. Wow, okay, so I actually have not read this inquiry at all. I've only just kind of breezed through it, but I did not know it had pretty much summed up what I was saying just earlier. So, although it did include that to just throw away information that's just not related to the subject, as we see here. I didn't really say that, but I mean, I guess that's pretty important too, is to just leave out information that just doesn't work. But sometimes when you do that, you kind of then you kind of start getting too much tunnel vision. I feel like if you start, I don't know. I guess you have to actually analyze it and then prove that it's worthless, and then reject it. So I guess you just have to kind of, here's what he's saying, is just reject everything after testing everything. Reject whatever doesn't work, and then leave whatever works. So I think that's probably better said than how I was saying it earlier. Okay. Continuing. To take a common instance, a child that has been burnt by a flame naturally expects the same result from the same cause. Indeed, he is said to feel sure of it from experience, and in the expectation of the same result from similar causes, he is said to reason by a species of induction, though not founded on an enlarged experience, but by trying experiments upon all objects which have the appearance of flame. He would learn to distinguish such as are hurtful from such as are otherwise, and excluding those that are harmless, he arrives at the conclusion that all such objects are of a particular kind are hurtful. Wow. That's like human nature in a nutshell. Wow. That's very well said. I mean, yeah, think about it. Like, you learn, at a young age that fire really burns and it hurts, right? So anytime you see fire, you're like alert, or it's like a danger sense to you. No matter what kind of fire it is, it doesn't matter what kind of fire it is. If it's a little flame or if it's your freaking kitchen on fire, if it's a forest fire, if it's a ball of fire, it's got the particular kind and which we deem hurtful or have such an emotion attached to it, or kind of experienced, or I don't even know what to put, but man. But see, like, yeah. Then I started thinking about, like, when it comes to, like, how we have stereotypes in, like, the different, like, races of people, and, like, how some people are naive to think that just because one type of person does something that the whole kind does it, but everything comes in all shapes and sizes, and humans are not of one kind, of any sort, or of any suit. There we go. There's some good logic and poetry for you guys can figure out. All right. Anyways, let's just continue. Now, in this statement of the process, it appears to me that two very different instruments are used. The first of which seems to be analogy, a reasoning upwards from the known to the unknown, the great instrument of invention and generalization, which provides, as it were, subjects for the exercise of induction, which induction seems to be rather the collection and examination of experiments, and the drawing a conclusion therefrom. And as this conclusion cannot be extended beyond what is warranted by the experiments, the induction is an instrument of proof and limitation. A person that has been burnt by a flame is positively certain that he will be burnt again if he try it. He argues only from same to same, and is sure of it by experience, and it is upon this innate natural expectation that all physical science is founded. By analogy, he argues that all flames will burn him. He argues from like to like. He generalizes and draws an interference. And I conceive it is by this analogical reasoning that all science is advanced. The interference which he thus draws as a priori is merely a hypothesis, a supposition, probable indeed, but far from satisfactory. But when he brings it to the proof by induction and collects experiments, he either confutes, proves, or limits this hypothesis to something not quite so general. This analogical reasoning, when it is extended only from individual to individual of the same species, is commonly called experience and not analogy, and from the perfect uniformity of nature, perhaps not improperly. Thus we say we know by experience that all stones gravitate to the earth. But when we extend it from species to species of the same genus, it is analogy properly so called. If from gravitation all stones we reason to that of apples, we reason by analogy, from like to like. We obtain a probable conclusion not satisfactory till the experiment be directed to the point, and it to be proved. Having thus included apples as well as stones, we may proceed from one species to another by the same process of analogy and proof, till all bodies upon the surface of the earth be included under the general law of gravitation, whence we may rise to more general propositions. And I am inclined to think that such has been the common process of discovery in all ages of the world. Wow. I don't even need to explain any of this. This guy's just kind of speaking pretty generally, and I don't know. I think this is like a third grade level. When Sir Isaac Newton, from the fall of an apple, was led to the consideration of the moon's gravity, he is said to have made the discovery by induction, which is true as far as the proof of it went. But it is manifest that at first he merely formed a probable hypothesis by analogy, and then laboriously brought it to the test of observation, and it is highly probable that the hypothesis he formed was that the moon gravitated to the earth with a constant force, instead of a force varying inversely as the square of the distance, which is most likely what was the result of another hypothesis, after he had proceeded so far as to ascertain that she did really gravitate, but not according to the law presumed. What the hell? Fascinating, really. I mean, I kind of already knew the story of Isaac Newton, you know, like, he looked at the apple, it fell, and then he's like, oh, does the moon fall too? Wow. When Harvey observed the valves in the veins, he is commonly said to have made the discovery of the circulation of the blood, by reasoning from final causes, or by asking of nature for what purpose such valves could be intended. But perhaps he might have asked the question forever, unless analogy between the valve and that of a pump had suggested a plausible hypothesis, which he proved by repeated experiments directed to the point. Analogy, so much slighted and overlooked, and to which such an inferior part in the advancement of science has been assigned, and that too with so much suspicious caution, appears to be the great instrument of generalization and invention by which hypotheses are supplied, which are most commonly the subjects for exercise of induction. Yeah. Well, analogies are really, really powerful things. That's really how I see. That's how I work. I really like. I take one, what I look at and what I've done before, and I just, I think about like how it gets put into that, situation, and I think about like, what are the patterns? What am I looking for? I'm looking for like resonance, and it's always about looking for resonance, or like speeds and feeds. If you know what I'm talking about. So. Let's see here. Oh, where did I leave off? Oh, well, I think I left off like right here. By induction, as usually understood, we make it a rule to exclude all hypotheses. First of all, we collect the experiments, and having obtained these, we are next to examine. Excuse me. Sense some like acid reflux. Let me reread that. Okay. First of all, we collect the experiments, and having obtained these, we are next to examine them and compare them. We reject the irrelative and negative, and conclude upon the affirmatives that are left. By this means, says Lord Bacon, we question nature, and conclude upon her answers. Yet I would venture to suggest that 99 times out of 100, the analogy or comparison precedes the collection of the experiments. Some resemblance is observed, some hypothesis started, which is the subject that is brought to the test of induction. Yeah, that makes sense completely. Analogy comes completely first. You see something and you want to relate it to something immediately. Immediately you want to start labeling it, analyzing it, and then you do the induction. Got it. It's like observing and then testing, of course. And this is a scientific method, but anyways. By this, the hypothesis is either proved or confuted, or more commonly limited to something less general. I would not be understood to assert that the common inductive method is barren, for, no doubt, discoveries are sometimes so made, but thousands and thousands of inventions are brought into play, and the result merely of analogy in a few experiments or a single experimentum crucis. By the common method proposed, we take too wide a range, we embrace the whole subject at once, and require the completion of its natural history. But by the proper use of analogy as a guide, we step cautiously but from one species to the next. Induction has two instruments of operation: experiment for all things within our reach, and observation for those beyond us. And of these, observation is less efficient than experiment, for it is comprehended in it. By induction without analogy, we first ask innumerable irrelative and impertinent questions of nature, and then make use of observation upon the experiments in hand. But by induction with analogy, we try experiments for a specific purpose and obtain specific answers to the point. Yeah, okay. I see that. It's like we see like a flame, right? So we just assume right away, oh, it's fire. And then like, okay, so now we got to prove that it's fire. So let's test everything that we know about fire to be true with this flame. And then you keep testing it, and then boom. And then that process of like doing the experiment is the induction. And that's why when they use induction, they have the suffix ion when they're saying this. So that's why it's the main process that occurs. And then the analogy is just, it's like making the guess, and then you test it. But you're testing for a specific purpose, which is what you're testing to be what you're assuming. And then, after the induction, you see what's there and what's not there, and then you just throw away what's not there, and then you're left with it. And then, I guess you go from there. Interesting. All right. I think I really hate to like break this up, but I'm gonna have to continue this right here in the next video. This is like in a really bad spot for me to stop, because this is really going deep into it, but there's a lot going on in this text. And also it's like not recognizing where I'm highlighting. I don't know what that is, but we're gonna leave off right here in this spot. I don't know how to, maybe if I highlight right here. Oh, so weird. Alright, let me highlight there. Alright, so we're gonna start here. And I'll try to do like a summary like right before we get into it, just kind of like what we were looking at. I really didn't know this was going to use induction and inductive reasoning. It was like, part of like his philosophy, but because I came up with this YouTube channel kind of on my own, because I'm an electrical engineer, and the way you look at things is like, the way you look at like motors and stuff, right, is you have like a inductor and a stator. And then the way it usually goes for like a motor or a generator, right, is you have the stator, which is the inductor, and then you have the rotor, and then the rotor, that thing spins, and that's creating either energy or then vice versa. But the stator is with a generator, you have the stator kind of inducing the magnetization from the rotor. So the rotor is like creating a bunch of magnetization fields and stuff like that, and moving magnetization fields, and then it powers the generator, or the generator, but the stator, which is also called the like the inductor, and it's like this whole like current thing, and then that gets sent to like the rest of the load and stuff like that. So I really didn't know it was going to start using induction as like a key tool and analogy too, because pretty incredible. Like I said, having the same conclusions and seeing other people with the same conclusions is telling you that you're on to something, or you're moving forward with a very potent idea, so to speak, if it is just a mere idea, not a fact yet. So anyways, this is a really long video, so I'll continue, like I said, where we were, and summarize it a little bit before in the next video. So continue on.